1 start.
Good morning, bachcho. In this class we are going to cover shear force and bending moment analysis of beam. Today course objective of this unit is to learn the definition of beam, types of beam, then definition of shear force and bending moment, and lastly we will learn shear force diagram and bending moment diagram for various types of beam. So let's start with the definition of beam. Beam is a structural member. Beam is a structural length member which is always subjected to transverse loading, which is always subjected to transverse loading. Why we are calling it structural length member? Because length of beam is quite larger in comparison to breadth and depth of the beam. So it is a structural length member, right? Examples of the beam are concrete beam, which we are using to make our roof, steel beam, railway track lines, and nowadays we are using steel as a beam for making roof also. Now we will discuss the types of beam. On the basis of analysis, we can say analysis point of view, from the analysis point of view, we can categorize beam in two parts. First, statically determinate beam, and statically indeterminate beam. So what is a statically determinate beam? It's statically. Word statically here stands for static equations. The beam which can be determined by the use of static equations, or we can say beam which can be analyzed by the use of a static equation, that is sigma fx equal to 0, sigma fy equal to 0, and sigma m equal to 0, is a statically determinate beam. So I am repeating again, beam which can be analyzed by the use of static equations, sigma fx equal to 0, sigma fy equal to 0, and sigma m equal to 0, is statically determinate. And beam which cannot be analyzed, beam which cannot be analyzed by the use of static equations is statically indeterminate beam. So, statically determinate beam which is analyzed by these three equations statically should have the number of unknowns three, meaning that means number of unknowns for a statically determinate beam should be less than or equal to 3, and they are not being analyzed, they cannot be analyzed by the static equations. That means here in case of a statically indeterminate beam, number of unknowns will be greater than 3, right? So let's discuss first statically determinate beam. There are three basic types of statically determinate beam from our subject point of view. First is simply supported beam. Second, overhanging beam. And third, cantilever beam. Sometimes people also classify these three beams on the basis of supports over the beam resting. So simply supported beam, this type of beam rests over simple supports. Simple supports, combination of instant roller, and always apply reaction in vertical directions, and then they take load always vertical one. Overhanging beam, here beam overhangs either one side of support, or both sides of supports. In case of cantilever beam, one end of the beam is fixed and other end is free to take load. This is cantilever beam. So our first objective is completed. First two objective, definition of beam and types of beam. Now we discuss the types of statically indeterminate beam. They are also categorized in three parts. First, fixed beam, which is the part of our syllabus. One in here, in case of this beam, both end of the beam is fixed, right? Second, propped cantilever beam. Here, one end fixed, another end hinged or roller supported. And third, continuous beam. Beam rests over more than two supports. Here beam rests over more than two supports. So this is continuous beam. In previous section, when we are studying statically determinate and indeterminate beam, we have said in case of a statically determinate beam, number of unknowns is always less than equal to 3. So here we can see in case of statically determinate beam, number of unknowns in case of simply supported is one reaction is here, one reaction is here. In case of simply supported, it is 2. In case of overhanging beam, it is also 2 or 3. When hinged, offering resistance only vertical direction. When there is inclined force, and there will be inclined force, there will be a vertical and horizontal component of this is vertical and horizontal component of reaction for this hinge support. So number of unknowns is 3. Here in this case, fixed support is always offering resistance in 3 direction, right? Number of unknowns is 3. So we are finding in case of a statically determinate beam, number of unknowns is always less than equal to 3. But here in case of a statically indeterminate beam, there are 2 fixed supports. So 3 unknowns are here and 3 unknowns are here. Total number of unknowns are 6. These are greater than 3. And static equations we have are 3. So static equations can be used for the equations solving for 3 unknowns. Here unknowns are 6, so they will not be suitable, they cannot be used for fixed beam. Similarly here number of unknowns are 4 and here 2, 1, 1, 4, right? There are some other methods are used for analysis of fixed beam, cantilever beam and continuous beam. So this beam is the part of our syllabus. At the end of this unit, we will discuss fixed beam, right? Now come to the shear force and bending moment analysis of beam. Shear force. Here the word shear is used because this force is trying to shear of the beam. Suppose here is your beam. It is subjected to vertical load along this section, across this section. These are the external loads. F1, F2, F3 and so on. Beam itself will provide a resistance against these external loads. It will try to prevent the shearing of the beam through these external forces, because this force is trying to shear up the beam along this cross section. So basically we can say for the equilibrium of this section of the beam, external force minus internal resisting force should be equal to 0, right? So external force, we can say internal resisting force equal to external force. This internal vertical resisting force is shear force, and external force is summation of all vertical unbalancing forces. Right? So shear force is basically the resistance force set up by the beam says resistance force set up by the beam itself against the external vertical unbalance forces. Now sign convention of shear force. Sign convention of shear force. Now we will discuss sign convention in next part. I have a time foundation. This is all about this lecture. Okay.